Today you will be learning index laws, the 5 basic laws of exponents. So make sure you listen carefully to our discussion and don't forget to take down notes.
Mathematics Online.
Alright guys, today we will be discussing index laws. So first, what do you mean by index? Index means these are exponents. Alright, these are exponents, or sometimes we call this one as powers. So what is the use of this exponent? Alright, how do we use exponent? Exponents are used to multiply numbers, right? Multiply numbers or variables by itself. Alright, so index means exponents, so these are powers. These are used to multiply numbers or variables by itself. Now, I have here, for example, a to the power of n. And here is our exponent, or this is our index. And a here is the base, or sometimes this is called coefficient. Alright, sometimes these are called coefficients, and or sometimes these are called constants. Okay, so basically a to the power of n stands for exponent or index, then a is for the base or coefficients, or sometimes these are called constant. Okay, now to study a certain index, now we are going to be familiarized with the laws of index. So the first law, all right, of index will be what we call product, right? Product rule or law. All right, what do you mean by product? So from the word itself, all right, from the word product, it means multiplication. Okay, multiplication. So the pattern for this would be, all right, the pattern for this would be if you have a to the power of n times a to the power of m is equal to a n plus m. All right, so this is the pattern or the equation. So notice that this is the multiplication. Right, this is the multiplication. That's why it is called product rule. Now the rule is, okay, once you have this, the rule is copy the base, then add add exponents. All right, so this is the first rule or the first law, product rule. A to the power of n times a to the power of m is equals to a to the power of n plus m. So means to say copy the base, add exponents. So this is the first rule. Now let's have an example. All right, let's have an example. So if I have 2 to the power of 3 times 2 to the power of 2, this is equal to, now we copy since, all right, look at this, same base, all right, same base. So what we do is we copy the base 2. Next is we add exponents. So these exponents here will be added, so it becomes 3 plus 2. So it is now equal to 2 to the power of 5. Okay, 2 to the power of 5. So that's how we simplify exponent. All right, same base means to say, because it is same base, the rule is copy the base, then what you do here is add exponents. Okay, now we proceed to the second rule, or the second law. All right, the second one is what we call the power rule, or law, the power law. All right, the pattern for the power rule will be, right, the pattern would be a to the power of m and raised to the power of n. Okay, a power raised to another power is equal to a to the power of m times n. So means to say, the rule explains that if a power is raised to another power, multiply the power. Okay, so this is the rule. Okay, and what you do is you just simply copy the base. Okay, for the second rule, we have power rule. If the power is raised to another power, multiply the power and copy the base. All right, let's have an example. Okay, for example, we have 2 to the power of 2, then raised to the power of 3. Notice, a power raised to another power. So it becomes, now, we copy the base. Now, what you do is, you copy the base. So therefore, this is 2. And then, multiply the exponent. So it becomes 2 times 3. Right? 2 times 3. Then when we simplify this, it becomes 2 to the power of 6. Alright? Okay, this is the second rule, the power rule. Next, we go to the third one. We call it the quotient rule. Alright, the quotient rule or the quotient law. Alright, what is a quotient rule? There will be 3 conditions. Now, for the quotient rule, you have to observe 3 conditions. What are these conditions? The first one is, alright, the first one is m is greater than n. Alright, that's the first condition. Now, the second condition is m is lesser than n. And the third condition is m is equals to n. So what do you mean by the first condition? M is greater than n. When you divide constant or base that is the same, for example, a to the power of m over a to the power of n, and m is greater than n, the answer will always be a to the power of m minus n. Alright, that's the first condition. Second, if you are going to divide the same base also, a to the power of n, then a to the power of n, and n is greater than m, then therefore we're going to solve it in the denominator. So it becomes a n minus m. Okay, now when a to the power of m, then a to the power of n is equal. So m and n are equal. The answer is 1. Alright? So if m is greater, you solve it in the numerator. Once m is lesser, then you solve it in the denominator. Once they are the same, the answer will always be 1. Alright? Example. Alright, let's have an example. For the first condition, m is greater than n. Example, I have 2 to the power of 3 over 2 to the power of 2. Alright, so we go for 3 is greater than 2. Correct? So therefore, our solution would be 2 to the power of 3 minus 2, which is equals to 2 to the power of 1, or this is just equal to 2. Now let's go for the second condition. which is m is lesser than n. Now what if I have 2 to the power of 4 over 2 to the power of 7? So therefore 4 is lesser than 7. Alright, so the solution would be you copy the base, which is 1 over 2, 7 minus 4. Right, which is equals to 1 over 2 to the power of 3. Right, we can simplify that further. It becomes or 1 to the power of 8, because this one is just equals to 2 times 2 times 2. Alright, now let's go for the third condition, which is, alright, the third condition, which is m is equals to n. So therefore, if I have 2 to the power of 3 over 2 to the power of 3, therefore 3 is equals to 3. Therefore, our solution would be 1. Because we just simply cancel this one out and it leaves us into having 1 there. So 1 divided by 1, and the answer is 1. So this is the third rule or the third law. You have to observe 3 conditions. Okay? Next, we go to the fourth one. Alright, the fourth rule. Alright, the fourth rule is what we call zero exponent. Alright, zero exponent. You have to understand that anything raised to the power of 0 is equal to 1. Alright? Anything that is raised to the power of 0, the answer is always equal to 1. The pattern is a to the power of 0 is equals to 1. So anything that is raised to the power of 0 is equals to 1. Example. Alright, example. I have 4 to the power of 0, the answer is 1. Alright. Second example, if we have 4x squared y 0, okay, the answer will become 4x squared, because this one here is equal to 1. Alright, so 4 times 1, the answer is 4, so it remains. So what if you have here 4 x squared y squared z0 and t1. Right, so you're going to observe this is the only thing that is 0, so this is 1. So therefore you copy everything. So 4x squared y squared t to the power of 1, or 4x squared y squared t. So these are our example for the fourth rule. Now we go to the last rule that we're going to have today, the fifth one, which is a negative exponent. Alright, the rule is anything, alright, any exponent or index or power that is negative should be made positive. Alright, positive. Anything that is negative should be made positive. So for example, the pattern would be if I have a to the power of negative n, this is equals to 1 over a to the power of n, so that the n becomes positive. Or if I have 1 over a to the power of negative n, it becomes a to the power of n. Okay, you get the reverse of it. Okay, you get the reciprocal of it. So therefore, this negative here will become positive. This negative here will become positive. So negative becomes positive. All right. So negative becomes positive. All right, let's have an example. All right, let's have an example. If I have 1 over 4 to the power of negative 2. Notice this is negative. So we have to make this one to positive. So it becomes now 4 to the power of 2 because you move this one up. Okay. Now what if we have another example? So what if I have 2, right? What if I have 2x negative 2 over 4y negative 2? Alright, notice this one here is negative, this one here is negative. So these two should be made positive. So therefore the solution here, 2 should remain there and 4 should remain here. Because the only thing that is negative is this x here and this y here. So therefore we move this 2 on opposite one. So therefore it becomes y to x2. Interchange so that those negative exponent becomes positive. Alright, and then we simplify further. Alright, so this becomes y2 over 2x squared, or this is y squared over 2x squared. Alright, this is your final answer. So this is how we do negative exponent. So let's have a short review with this. Alright, let's have a short review. First, we define what we mean by index law. Index law is called also exponents or powers. Literally, use exponent to multiply numbers and variables by itself. Alright, so we have here, this is what we call the base, or sometimes called coefficients or constant. And we have here, this is our exponents, index, or sometimes called powers. Now, what are the laws, the basic laws of exponents or index? Now, the first one is the product rule. Product means multiplication. So you can see here in the pattern, you do this. That's what I mean by multiplication. So when you multiply same base, what you do is you add the exponent, you copy the base. That's what the rule means. All right. So you have example there. Now let's have the second one, which is called the power law or the power rule. Now, when you have a base, all right, and you have power to raise to another power, what you do is you multiply the power. So that's what the rule is. If the power, right, if a power is raised to another power, multiply the power, and then you copy the base. All right. And copy the base. So we have example there. Now next, the next one is quotient rule or the quotient law. Quotient means division, right? Quotient means division. So therefore, but when you do division, you have 3 conditions. The first condition is m is greater than n, m is lesser than n, and m is equal to n. So we have the pattern here. All right, so observe the pattern. All right, anything that is equal to 1. All right, we have example here. Now what next? We go for the fourth one, which is the zero exponent. Anything that is raised to the power of 0 is equal to 1. Anything. So right, this is equal to 1. Remember that one always. Anything. The only thing that you have to remember is the only one that has the power of 0 is the one that you are going to equate to 1. Only that. Now, the last one that you're going to study now is what we call the negative exponent. All right? Any exponent that is negative should be made positive. So you get the reverse of it or the reciprocal of it. Negative becomes, remember that, negative becomes positive. So we have here examples. So don't forget, guys. So if you have any question, feel free to ask and leave a comment here. And don't forget, there is a worksheet after this. All right, so I hope you understand what we're trying to discuss today. This is the last topic before midterm. So I hope if you have any question, feel free to ask, and I hope there will be, if you have any question, ask me. If none, then I hope the topic that we have today is understood about index law.